I'm Maria Varmazes, host of T-Minus Space Daily, and this is AWS in Orbit, Modernizing Satellite Management. Today, we're bringing you the next installment of the AWS in Orbit podcast series from the 40th Space Symposium. In this episode, I'm speaking with representatives from Arcfield Orion and AWS Aerospace and Satellite. And we're going to do a deep dive into the challenges that the AWS modular framework for satellite operations solution solves. Gentlemen, thank you so much for joining me today. I think this would be the perfect time for us to do some intros. So we're going to go from my left to right, if you don't mind. Could you please start?
Yeah, happy to. Appreciate the opportunity to be here today. My name is Junk Wilson. I'm a Senior Vice President with Orion Space Solutions. We're an Arcfield company, and I am really excited to talk to you today about one of the solutions that we've developed called Orbit IQ. A little bit about my background. I started my career in the Air Force. I was a graduate of the Air Force Academy with a degree in physics. Spent about 20 years flying fighters. So I flew F-15s and F-117s, fantastic airplanes. Really enjoyed that, several overseas deployments. And then after I retired from the military, I got back into physics and realized that I really had a passion for understanding how the space environment is impacting a wide variety of things from satellites to our civilization here on Earth. With Orion, I've had the opportunity to lead a team that we call Models and Applications. And within that team, we've developed some fantastic technology with the help of AWS, and we're really excited to share that with you today.
I'm looking forward to learning more about that today.
Hey, I'm Ed Maletian. I'm a solutions architect at AWS, part of Aerospace and Satellite. And I'm going to be talking a little bit about dynamic node orchestration on AWS. I'm excited to share that later on, but my background is mostly in mission design, mission planning, scheduling. I started my career at Raytheon, working on weather satellite programs, and I've eventually worked my way through different mission domains over to rendezvous proximity operations missions, something really dynamic, space situational awareness, and some other kind of interesting projects before I came to AWS to help customers leverage the cloud to do things at scale in a way that's reliable and really push the envelope on what the technology can do.
Very cool. Thank you.
I'm William Dewey. I'm a senior software engineer with AWS. I work for the AI/ML team. I like to consider myself a technologist, jack of all trades, software sorcerer, love everything technology. My background's in physics and computational mathematics. Academically, I was trained in cosmology and particle physics. Transitioned from that into the software engineering world with Silicon Valley. I've worked with Maxar, Lockheed Martin, and some of the biggest aerospace companies in the world that provide satellite imagery at scale to customers around the world. That's transitioned me here to AWS, where I've leveraged those skills with the AI/ML team to develop pipelines, tools, and a specific tool called Oversight ML that we're going to be presenting here at the conference that helps customers adopt the cloud for these mission-critical software solutions.
Yeah. Well, I'm looking forward to learning all about that as well. So, Junk, Ed, and Dewey, thank you, all three of you, for joining me today. So why don't we sort of set the stage first? So I know each of you sort of has a component of the framework that you are going to be talking to me about. So, Junk, can we start with you? Tell me a little bit about Orion Orbital IQ.
Yeah, happy to. So, we are a space company. We build and fly our own satellites. And about 10 years ago, we realized that the free products that are available from NOAA Space Weather Prediction Center, or SWPC, as it's known, really weren't meeting our needs completely. They're a great product, and it's, we're great to be, partners with SWPC, but they didn't give us the fidelity of data that we needed about the Earth environment to really understand where our satellite was going to be and when was it going to be there. And that has a wide variety of implications, not the least of which was, we have to buy antenna time in order to talk to our satellite. And so if we are off by even a few seconds, those few seconds of antenna time that we buy are really expensive. And so we realized that for our own purposes, we needed a better orbit propagation solution, and we needed to really reduce the uncertainty in that math calculation, which the largest source of uncertainty below a certain altitude anyway is drag, is neutral density, and understanding how that neutral density is impacting it. A lot of people think that when you are in low Earth orbit, you're in the vacuum of space. And it's certainly lower pressure, but it's not actually a pure vacuum. And so that neutral density and that drag force is actually really significant. We started investigating what it would take to run our own models. We are a company full of computational physicists, so we thought we could do our own pretty well. And we realized that what was available in the market at the time didn't have quantified uncertainty. You could make some guesses. You could say, hey, I think there's about this much uncertainty in these various numbers. But from a computational science perspective, that was deeply unsatisfying. So we realized we had a problem for ourselves that we needed to solve. There was nothing in the market yet that could do it. So we decided to take that on as a challenge and see if we couldn't not only solve our own problem, but maybe turn that into a solution that could be a marketable thing that could be part of a larger enterprise. So Orbit IQ builds on that legacy of, we think of it as being, by owner-operators, satellite owner-operators, and for owner-operators, right? So we know what you need because we are you. We are people who fly satellites, and we have our own satellites, and that's super important to us. One of the things that's really unique about Orbit IQ is that it runs a variety of ensembles. So if you're not familiar with that term or what that means, it's very similar in nature to the hurricane weather forecasters that you see on TV, right? You've probably seen those spaghetti charts where it looks like the hurricane could hit any one of a number of places. Every one of those lines of spaghetti is a member of an ensemble. And all of those lines of spaghetti together form an ensemble. And we do the same thing in space environment modeling. So rather than just run a single model of the space environment, we run over 100 models of the environment, and we take every one of those outputs and feed that into our orbit propagation software. Our orbit propagation software is also unique in the fact that it was designed from the ground up to be run like a Monte Carlo scenario. It's another type of ensemble, but the two ensembles are actually tuned to work together. So we have an ensemble of space environments models, and we run that with an ensemble of propagation models. And together, what that allows you to do is it allows you to sample the population of the ensemble at each step and give you measured uncertainty. So some of the other products in the market will say things like, oh, well, we assume a 7-kilometer uncertainty bubble around our spacecraft. We don't have to assume anything. We model it over 100 times in a row, and we do it in parallel, and we run the model and the orbit propagation together. So we actually have a measured uncertainty bubble. And it turns out that our uncertainty bubble is significantly smaller than what everybody else is assuming. So from a space traffic management or from a conjunction assessment perspective, if you have a whole bunch of relatively large bubbles, you're going to get an awful lot of false positives. You're going to think that things are running into each other when in fact they're actually quite far apart. And only with the measured uncertainty provided by Orbit IQ, with the help of AWS, of course, can you actually get that precision and that measured uncertainty so that you can actually do the space traffic coordination and space traffic management that we all know is necessary in this modern space age.
Yeah, I was going to say that sounds transformative for space domain awareness, which, kind of a hot topic.
Absolutely. I mean, one of our favorite things to do right now, we are working with the Space Domain Awareness TAP Lab here in Colorado Springs, and they have a whole variety of problems that they're trying to solve, not the least of which is trying to understand what's called camouflage, concealment, and deception maneuvers, CCDM. I think we all know that not everybody in space is a friendly actor anymore. And so there are an awful lot of times where people are doing one thing, but they're saying another. And the only way to separate those two is with very accurate understanding of the uncertainties associated with orbit propagation and orbit determination. So we love to work with the SDA TAP Lab. It's a fantastic organization, and we know AWS is embedded there too, so we're really excited to continue that partnership there.
Fantastic. Now, Ed, I'm going to move to you because we were talking about, being able to understand better risk in orbit, and now I'm thinking about also how satellites are going to be communicating with each other. So I feel like this is a good time to introduce sort of your component here.
Yeah, so I'm going to be talking a little bit about dynamic node orchestration on AWS. And really this came about from a need in the space industry to do physics and network simulations at scale. And what dynamic node orchestration on AWS, or I'll call it Dyno for short, what it does is it lets customers build digital twins of very complex dynamic systems that may have thousands, tens of thousands, or hundreds of thousands of moving nodes. And a node could be a network device, a router, could be a ground station, it could be a satellite, it could be a person or an aircraft. So all these things can work together to accomplish a mission. Now, how well are these things going to work together to accomplish that mission? It's really hard to say in a very dynamic environment when none of the nodes really have any idea of what the other nodes in the system are doing. That's why we built this digital twin, to bring all of those things in a virtual form into the cloud and be able to connect them and make sense of them at scale. And what Dino provides is a platform for customers to do that by bringing in data about positions of all these nodes, about their capabilities, any constraints that they have.
Yeah.
Dino will orchestrate their motion, their connectivity, and build the system for you. And what that means is, if, for example, you have a satellite constellation, all of these nodes are in the constellation are linked to each other via either optical links or RF links. And the operator has questions. What is my latency from node A to node B? Node A might be an aircraft and node B is a satellite. What happens if one of my nodes goes down? How does my network self-heal?
Yeah.
How do I reroute around a specific geographic region?
Yep.
None of these nodes know about the nodes that they're connected to. So it's important for someone to understand the system holistically, to be able to take inputs from an operational environment and then be able to optimize the digital twin, and from that, optimize their operational system.
Okay.
So when a node says, hey, is sending back unhealthy signals or not communicating, you're updating your digital twin to say, take this node out and send me new routes that I can proliferate through the rest of the network. And then sending those commands out to everything so things know what they're going to connect to and when.
That sounds like it would also save a lot of time for the customer. Just listening to that. Yeah.
Yeah, exactly right. For example, they don't need to, it'll save time in terms of, I know how to optimize which data path a specific maybe imagery collection needs to take, and I can orient my network in a way to optimize that path.
Yeah, makes a lot of sense. All right, now I'm going to move now to what happens with the data once it's acquired. So Dewey, this is sort of turning to you now. So we're talking about OSML. Tell me a bit about that.
So oversight ML, short OSML, is what happens at the very end of this pipeline that we're discussing here amongst the three of us. We have Orbit IQ and Dino, which are helping to sustain satellites in space, manage them, keep them from running into other objects. But what happens when we get this data down to the planet and we want to orchestrate the release, dissemination, analysis of that data at scale? In the last 5 or 10 years, there's been a proliferation of data that's being made available, increasing resolutions, increasing complexities, increasing formats. And customers have had a challenge to adopt the cloud as the place at which they do all the processing for this imagery. Processing can include normalization, release of that data to specific customers, the application of AI ML, which we'll be kind of focusing on in these demonstrations here with Oversight ML. Oversight ML is a broad framework of solutions and tools that are all open source. We provide them through GitHub for customers to download and use in order to increase their velocity in adopting the cloud as the ecosystem they use for processing imagery. Model Runner, which is our focal tool of this conference, specifically empowers customers to process overhead imagery against computer vision models efficiently at scale. When you have thousands, tens of thousands of high-resolution images coming in from these satellites, how do you manage that data flow of taking an image and getting insight out of it? If we look back to the 50s, 60s, 70s, when we were first starting the process of collecting overhead imagery, we had hand analysts going in and circling object of interest, recording that in a table, a notebook, a database, sharing it with their colleagues, and then making strategic decisions based off of that. With the advent of computer vision and AI ML, all of that's being automated away. How do we efficiently take these behemoth-sized images and distribute them to computer vision so that we can go from image to insight in a velocity that makes sense for our customers?
That the fact that is automated is, sort of table. It's just amazing to me that that is where we are at. The insights that have to be delivered from that are just, and the speed at which it's coming is just, it's got to be game changing.
It really is. And especially when you consider national defense agencies, governments around the world, people that want to respond to natural disasters.
Yeah.
And sometimes going to insights in minutes or hours
Yep.
makes all the difference in an organization's ability to effectively respond to a situation.
That's quite amazing. All right, well, gentlemen, we've talked about sort of each of the components here. Ed, I'm wondering if you can give me sort of a sense of like a through line for the framework here, just to make sure that we're sort of aligned here. We can give that a shot.
Yeah, sure. I mean, this is a modular framework, so all these solutions kind of exist on their own and they provide their own value. But here we're bringing them all together to show how customers of ours can do space management at scale. And Orbit IQ is kind of where it all starts. This is a foundational capability that almost every space mission needs to have, knowing where satellites are to a very high degree of accuracy.
Yeah.
And it's not just the satellites too, right? Like Junk mentioned, there's the ground station contacts. Like, when can I talk to my assets? The quantified uncertainty is a big piece of that. It also extends to space situational awareness, knowing where everything else is, and so just about everything is going to use that Orbit IQ piece.
Yeah.
Tell me if I'm wrong, but I'm betting for Dino, you really want to know where every node in your network is, right?
That's exactly right. So when Dino comes in and we have thousands of assets that we're modeling, those uncertainties stack up, right? So we need that high fidelity propagation to make sure our ground contacts are optimized. We're not losing any time there. If things are drifting out of position and maybe we aren't getting a contact that we expect, is something nefarious happening or something else? And Orbit IQ provides that backbone. And as customers of ours who operate many different Earth observation satellites, as they optimize their fleets using Dino, for example, we have a use case of how do we image every city on Earth every hour? Well, what do we do with those images is the next question, right? And that's where OSML comes in, is once we're piping all that data through the inter-satellite link constellations and sending that out to operators, we need a capability to do inference at scale in a very reliable way. And OSML is, especially the model runner piece, it's very good at that. So customers have a much easier time getting value and insights out of the imagery that they collect.
Fantastic. Well, thank you. Thank you for tackling that question. I know that was it can be a tricky one to answer. And since this is AWS in orbit, I have to ask, because I am genuinely also curious, when we think about each of these components working on their own or also in coordination with each other, what do they enable customers to do in using the cloud and AI with AWS? I don't know if anyone wants to tackle that one. Junk, you want to take that one?
I can at least start from our perspective. It is uncommon to have a team of astrophysicists like we have at Orion and have that group also be present in a satellite owner operators. Normally, satellite owner operators are a bunch of very talented engineers. Those are very different skill sets. So I think what this overall package provides satellite owner operators is this, that classic question of, do you build it or do you buy it? It is possible, like some other satellite company could go out and hire a bunch of PhDs in astrophysics, pay them their annual salary.
I was going to say, notoriously cheap, right?
Yep, spend a couple of years developing and testing and validating all of these models. Or I think what AWS offers now is, hey, this is now a ready-to-go package solution. Buy it off the shelf because it's packaged by AWS. Install it right in your own personal AWS account and feed it what you want to feed it. So you could hook it up to internet data. You could hook it up to your own satellite data if you have your own small constellation of satellites. You could run it inside your own little protected network if you're worried about data security. You have an infinite number of options there because AWS gives you all those options, and this is one of the solutions that seamlessly plugs into that architecture.
It's very cool.
And if I could expand a little bit on what Junk is saying here, I think that scale is one of the focal points of what our customers need as we begin to expand what we do in space. When we look at the last 20 years, the amount of components and hardware and devices that we have in space has gone up exponentially. Space is quickly becoming crowded, I think is a phrase that I've heard
a lot
in the industry, right?
Well, one of my favorite analogies for that is more mass has been launched in the last 5 years than had ever been launched in the history of humanity up until 5 years ago. Ooh. That's an amazing thing to think about.
It really is. And as that scale increases for the amount of hardware, collection, and data that we have available for our customers, how do they operate in a way that allows them to scale as those continue to increase for the next 2, 5, 10 years, as the amount of hardware increases required to do the compute for the sophisticated orbital modeling, for the dynamic traffic simulation, for the data analysis on the back end? AWS is kind of the king of scale in the market. And by plugging into these types of ecosystems, it allows customers to adapt to a rapidly evolving techno landscape, which is space operations.
Yeah, absolutely.
Yeah, in terms of the orchestration piece too, AWS provides a lot of flexibility. So customers can bring tools that they're familiar with that they can let AWS handle the orchestration of things that most customers don't make money off of in terms of, IT operations and scaling and having to figure out, how much hardware do I need? How much staff do I need to maintain that hardware? AWS kind of handles all of that, right? And so if you bring on a new mission or maybe you have new customers asking for your data, you don't have to go back to the drawing board and figure out, well, how many more servers do I need? These serverless offerings that we offer, they scale on demand. So if you need more capacity, you get it and you don't have to worry about it.
And I could speak to this too, because not only am I part of this team here, but Orion is a customer of AWS.
Right.
And, I can speak to the fact that Orion doesn't want to get into the business of cloud computing. That's not what we are best at, right?
Yeah.
Like, we're astrophysicists. That's hard enough. I don't need to be, a bunch of computer science guys too. I would much rather use the power of AWS and take all of that off my hands.
Not to mention the economics around how quickly is this hardware going to depreciate?
Right.
Oh, exactly.
How quickly am I going to need to buy the next generation of GPUs, the next generation of compute processors, FPGAs, all these different complex and quickly evolving hardware that we're using in space operations. AWS offers a framework for implementing all of these on the fly.
That's fantastic. Gentlemen, given that you all have such varied careers and perspectives on the space industry, I just have to ask, what are you most excited about when you look towards the future of what's coming? I mean, even just the capabilities that you all have described to me today are things that I think 5 years ago I would not have believed that we were doing.
Yeah.
So as you look forward, what's got you jazzed? What are you thinking about? I'll start left to right.
Yeah, I've got a lot. I'm a total
Where to
space
start,
nerd.
right?
Yeah, so I'll tell you, one of the things that gets me really, I can't wait to see this is when we get commercial suborbital rocket travel. How cool is that going to be?
I guess for me, it's the connectivity that's always increasing. So as we continue to launch new satellites that provide connectivity to very remote places on Earth and guaranteed communications to the rest of the world, I think that's really exciting to me. I camp a lot, so when I'm out in the forest and maybe I need to get a topographical map, it'll be really nice to go and find one on the internet when I need it.
And so my interest in space and where I think it's going and where it's going to impact humanity is a very cross intersection with philosophy and our understanding with our place in the universe. It's great to think about all these practical applications that space is going to offer us as we begin to be able to, for instance, ride rockets to the beach on Saturday.
Hell yeah.
Or, communicate with one another more efficiently and quickly.
Well, gentlemen, it's been a pleasure. Thank you so much for speaking with me today. I appreciate it. That's it for this episode of AWS in Orbit by N2K Space. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Laura Barber for AWS Aerospace and Satellite and by N2K producer Liz Stokes and senior producer Alice Caruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jennifer Iben. Our publisher is Peter Kilpie. And I've been your host, Maria Varmazis. Thank you for joining us.